Dear students, up to now we discussed about statistical quality control. What is statistical quality control? We know that what is statistical quality control? Control for manufactured product. It is used to control the quality of a manufactured product. And what is the important word in statistical quality control? We already know that the important word in statistical quality control is quality. It depends upon the four M's. One is material, manpower, machines, and management. And we know the causes of variations in quality. There are two causes of variations in quality. One is removable and another one is unremovable. They are also called as random causes and assignable causes. We can use the random for random causes. We can use natural tolerance limits and we can control them. And for the assignable causes, we have to use only control charts statistically. So here we use control charts, and these control charts are invented by W.A. Shewhart. So these control charts are also called as W.A. Shewhart control charts. These charts are very useful in statistical techniques to do every problem in assignable causes. Here we can control the quality of a manufactured product by using control limits. And Dr. Shewhart proposed 3 sigma limits. These are also called as 3 sigma limits, which has 3 control limits. They are: number 1 is upper control limit UCL, and number 2 is center limit CL, and number 3 is lower control limit LCL. These UCL and LCL both are dotted lines, and the central limit is a solid line. We know that if all the sample points lie between the upper limit and lower limit, then we say that the process is under the statistical control. Otherwise, we say that the process is out of statistical control. And we have two types of control charts. One is control chart for variables, and another one is control chart for attributes. In control chart for variables, we have discussed about X bar chart, that is control chart for mean, and R chart, that is control chart for range. And we have done the problems also. And in control chart for attributes, we have learned about the P chart and C chart. P chart is used for fraction defectives, and C chart is used for number of defects. We have discussed the problems also. Here, when standards are given, we have discussed, and standards are not given, we have discussed. When standards are given, then we can easily and directly substitute the values into the UCL and LCL. When standards are not given, then we have to find the values by using the formulas. Okay. Here, when standards are not given, we already discussed about this problem. First of all, we have to byhead the formulas X bar and R chart. And similarly, we have a control chart for attributes. One is C chart and P chart. In C chart is used for number of defects, and P chart is used for fraction defectives. Here, when standards are given, we can find out when standards are given, then we can directly substitute those values and we can find the UCL, LCL, and CL. But when standards are not given, then we have to use the formula, and with the help of SQC table values, we can construct control limits. SQC table values can be constructed by using sample size. Based on sample size, we can find the SQC table values. So this is the chapter about control chart for variables and control chart for attributes. Here we have to make a note that when standards are given directly, then we can use case 1. And when standards are not given, then we can use these formulas. In whatever the chart may be, when standards are given, he will give the direct values. And when standards are not given, he will not give the direct values. We have to find the values and substitute the values, and then we have to find the control limits. Okay, this is a chapter about control chart for variables and control chart for attributes. As per the JNT, we have C chart, P chart, and X bar chart and R chart. We have discussed the problems and we have discussed the methods how to do. And these are, at last, we have some of the differences between control chart for attributes and control chart for variables. Here we can easily we can identify the differences between control chart for variables and attributes. We can detect and control the variations here. We cannot detect here. Small samples are enough here. Here the large numbers are needed. We have to measure the quality characteristics. There is no need to measure. Here quality operators has to be well-trained operators are used. Here it is easy to decide. The process time taken, the process less expensive. The charts are sensitive, these are less sensitive. A variable is hardly used, these can be used. Some subsample sizes should preferably equal, they are unequal. Separate control chart is needed, no separate chart is needed. We can construct both X bar and R chart at a time in a single graph. Here we cannot, no need for combination of the charts. Thus, this is about the SQC, statistical quality control. This is the ending of a chart.